Good morning, grade sevens. Welcome to your daily lesson of mathematics brought to you by WorksheetCloud.com. Hope you guys are really well and looking forward to the week ahead. And let's get straight into our theme today because there's a bit to cover. So today we're going to be looking at areas. We're going to look at areas of different shapes. You should be able to remember quite a few of them from grade 6. But I'm going to throw in a few new ones there that perhaps this is the first time you're having a look at them. We've got our normal warm-ups, mental questions and challenges on either side of our main theme. All that's left for me to say before we start is please use the email address on the bottom of your screen, grade7@WorksheetCloud.com. Send me any questions or related queries and I'll be more than happy to answer them. Okay, so our warm-up for today is to work out the value of those symbols and the pink question mark at the end. So off you go and do that. Press pause and then press play to see how you got on. Okay, so here I used a little bit of trial and error. I started on the 4th line and I just said that 5 times 4 equals 20. What I actually did originally was I said 4 times 5 equals 20, but when I worked through the rest of the puzzle, I realized that didn't work, so I had to change those values around. So my green sneaker is 5, and I know that the yellow shirt is going to be 0 because anything multiplied by 0 is 0, and I know that the shoe and the feather are 5 and 4, so I was looking for 0. Then the second line, I know that the sunglasses and the moustache are going to be 3 because 5 times 3 is 15. So 3 multiplied by 4 is going to give me 12. So that works out quite nicely. And then I've got 5 times 0 times 3. And we know that anything multiplied by 0 is 0. Okay. Well done if you worked that out. Here are your mental arithmetic questions for today. So there are 9 of them there covering past principles. So go ahead and work them out. Press pause. Take your time. Don't rush. Make sure you check your work. And let's see how you guys get on when you press play afterwards. I've done the first 2 for you already, just to save a bit of time. So when we're adding decimals, the important thing is to put the numbers in the correct columns. So you can see that 187,946 plus 417,745 is going to be equal to 605,691. And then the subtraction sum, where I had to borrow quite a bit, 20 minus 3,134 gives me 16,866. The check of that is to do the inverse. So for the first question, I would have said 605,691 minus 417,745, and that would have given me 187,946. So that's one check. And for the question at the bottom, I would have done the inverse and said 16,866 plus 3,134. Does it give me 20? Indeed it does. So therefore I know that I must be correct. Okay. Let's just clear some space for question number 3. Question number 3 is a long multiplication question, and I'm going to do it for you in a column method. Okay, so that's 143 multiplied by 52. So 3 times 2 is 6. 2 times 4 is 8, and 2 times 1 is 2. I need to carry the 0. 5 times 3 is 15. 5 times 4 is 20, plus the 1 is 21. I must carry the 2, and then 5 times 1 plus the 2 I carried is going to be equal to 7. And then when I add these numbers, I get 6, 13, carry the 1, 7,436. Okay, so that's just one method of doing it. If you had done doubling and halving, I think it would have taken you to 572 times 13. So still would have been a long multiplication sum. Yes, you could have split it up. It would have been entirely up to you. Short division question next. So 67 0.904 divided by 2. So we're just halving. So 2 goes into 6 3 times. 2 goes into 7 3 times. There's a remainder of 1. Remember, the comma goes in line with the comma in the dividend. 2 goes into 19 9 times. 9 times 2 is 18, so it leaves me with the remainder of 1. So 2 goes into 10 5 times, and 2 goes into 4 twice. Okay, then if you wanted to check, which I encourage you to do, multiply it by 2, multiply the answer by 2, and see if you get the dividend. So 2 times 2 is 4, 2 times 5 is 10, 2 times 9 is 18, plus the 1 is 19, carry the 1, 2 times 3 is 6, plus the 1 is 7, and 2 times 3 is 6, and you can see that that answer is the same as the dividend, so therefore I must be correct. Dividing by 10, so 125 divided by 10, and I'm sure we all know that the number will get one place smaller, so that gives me 12,5. And to check that, 12,5 multiplied by 10, does it give me 125? It does indeed. I'm going to do the division of fractions just below that. So we know that the 2 can also be written as 2 over 1. So we've got 2 fractions. Okay, and recall that the rule for division of fractions is the division sign changes to multiply, and the fraction after the division sign gets inverted, so that becomes 1 over 2. Now we've got 8 times 1 is 8, and 2 times 9 is 18, and that simplifies to 4 over 9. We can divide both 8 and 18 by 2. Alternatively, you could have said that 2 goes into 2 once and into 8 4 times, and now you can see in your numerator you've got 4 multiplied by 1, which gives you 4, and you've got 9 multiplied by 1, which gives you your 9 as your denominator in the answer. Okay, then straightforward multiplication of fractions next, and that's going to be 3/5 multiplied by 6 over 11. Okay, now I can't do any diagonal cancelling out here, so I'm going to go 3 times 6 is 18 over 5 times 11, which is 55. One's odd, one's even, so they can't be divided by 2, can't both be divided by 3, they can't both be divided by 4 or 5 or 6 or 7, so they're already in their simplest form. Then the last question, question 9, is a percentage question, and you've got different ways to work this out. 40% of 30, I can say 10% is equal to 13. So 40% will equal 13 times 4, which is 52. Okay, alternatively, you can say 40 over 100, which is the same as 4 over 10, which is the same as 2/5, multiplied by 130 over 1. Okay, we can simplify diagonally. 5 goes into 5 once and into 130. 5 is into 120 times, into 36 times. So that's going to be 26. And then 2 multiplied by 26 equals 52. And you can see you get the same answer. Okay, cool, guys. I hope you remembered those mental arithmetic problems based on previous work. If not, then go back onto WorksheetCloud.com and have a look at their previous lessons that we've recorded for you. Brush up on your fractions, your division of decimals, or whatever it is you need to practice. I think I left out question number 5. I think I've just noticed that. So let me go ahead and do that for you. My apologies about that. Let me just do question number 5 for you. So question number 5 is 1.5 minus 1/3. Okay, we convert to improper fractions. So 3/2 minus 1/3. Then we need the lowest common denominator of 2 and 3, which is 6. So 2 goes into 6 3 times. So 3 times 3 is 9. 3 goes into 6 twice. So 2 times 1 is 2. So my answer here is going to be 7/6. And if you needed to, you could convert that to 1 and 1/6. Okay, sorry about leaving out question number 5, but there you have it on your screen in front of you. Okay, let's get into the main theme of today. Okay, guys, our main theme for today is area, and I'm very aware that you would have covered this in grade 4, 5, 6, so the beginning will just be a short recap. So we know that the area of a 2D shape is what's inside the perimeter. Okay, and remember that the perimeter is the distance around the outside of the shape. So your perimeter there is going to be marked in red. Okay, and that's your units of distance for perimeter, metric and imperial. So this is all just a recap for you. The area of a shape is the measure of the surface or the space contained within its perimeter. So everything inside the red border of that rectangle is the area, indicated by the green that's just come up on your screen. And we know that area is measured in units squared. Because we are multiplying 2 dimensions, that gives us units squared. And there are your units of area. And you'll notice the exponent 2 indicates a squared measurement. Okay, and there is a 1 centimeter squared, which is literally a square made up of sides of length 1 centimeter. So 1 centimeter times 1 centimeter is 1 centimeter squared. Okay, so that is what we're trying to work out. How many 1 centimeter squares will fit into that surface that was contained by the red perimeter? And I'm sure you'll agree that by doing what I've just done for every single shape is going to be time consuming. So there's your answer, but we can also get that answer by multiplying the length by the width, which is 6 times 3, which is equal to 18 centimeters squared. So that should be more of a reminder for you, or a recap. Let's see if we can move on. Okay, so I've got some real life examples for you to work out. I'd like you to go work out those 5 areas, press pause, and then see how you guys get on. Is going to be length 100, width 50. So we know that the area of that's going to be 100 multiplied by 50, and that gives me 5,000 meters squared. Important to notice the unit squared. The basketball court is 90 feet times 50 feet, so more of an imperial measurement. But it doesn't matter if the units are metric or imperial, the same rules apply. You just multiply the length by the width. So 90 times 50, or 9 times 5 is 45. You've got 2 zeros in the question, so you know you must have 2 zeros in the answer, because in the question it's a multiple of 10 times a multiple of 10, and then that gives you a multiple of 100 in the answer. So 4,500 or 4,500 feet squared. Question 3, more of a American football field, I would say, than a rugby field. But again, same things apply. 120 times 40, or 12 times 4 is 48, and then add the 2 zeros, 4,800. For question number 4, you got a playing card, and there you've got halves. So 8 times 5 is 40, and then you need to work out the additional half times a half, and that's going to give you 46,75. So 8,5 times 5,5. You could have said 85 times 55 and then divided by 10 twice. Either way, you would have got 46,75 centimeters squared. You could have also converted to improper fractions. So you could have had 17 over 2 multiplied by 11 over 2. And then it would have given you the same answer on your screen. And then the snooker table or pool table, 90 centimeters times 210. So multiply the 9 and the 21 and you get 189, and then add in the 2 zeros. So I'm sure we all know the area is length times width. And just remember the mental multiplication strategies that we introduced to you right at the beginning of the lockdown, where you could have worked out multiplication sums a little bit easier, especially when you're dealing with friendly numbers. And remember, friendly numbers end in 0. So yeah, go back and have a look at those lessons if you're not 100% sure of those procedures. Okay, so after area of rectangles and squares, we get into area of compound shapes. So a compound shape is a shape made up of more than one rectangle. Or for now it's rectangles. You also get compound shapes which are made up of rectangles, squares, and triangles. But for now we're going to look at this compound shape. So you should be able to see that you can split up that shape into 3 different rectangles. Now there are 2 ways to do this, so I'll show you the second way next. So here you can see that you've got 24 centimeters squared for the vertical rectangle, 12 times 2. So you would have had to work out that width of 2 centimeters based on the other information given on the diagram. You could have worked out 2 times 4 is 8 centimeters squared for the top right rectangle, and the bottom right rectangle would have been exactly the same. Then you just need to add the totals together, 24 plus 8 plus 8, and that will give you 40 centimeters squared. The second way of working out this compound shape would have been to split the compound shape into those 3 rectangles. Now you can work out the middle one is 16 centimeters, 8 times 2. The top rectangle would have been 12 centimeters squared, 6 times 2, and the bottom one would have been identical. Then if you add up those areas, you still get 40 centimeters squared. So you can split it up how you prefer, whatever's more comfortable for you. Just make sure that you realize you needed to work out that width of 2 centimeters for the vertical rectangle before you do anything else. Okay, so that's area of compound shapes. Go ahead and work out the area of this compound shape. You are going to have to figure out missing sides, or the length of missing sides first, but press pause and let's see how you get on. Of the missing sides, well, first I'm going to split it up into different rectangles, and again you could have split them up differently, but the way I've split it up, I need to work out the length of that question mark at the bottom, and that's going to be 4 meters based on the top length being 8, and then the 2 shorter lengths on the left and the right being 2 meters. And then I need to work out the length of that question mark on the right, and that's going to be 3 meters based on the information I see on the left hand side. Okay, then I can go work out the areas. The top rectangle will be 8 times 2, length 8, width 2, so that equals 16 when multiplied together, 16 meters squared. The middle rectangle is 5 meters times 4 meters, so 20 meters squared. And the right hand side rectangle is 3 meters times 2 meters, which is 6 meters squared. All that's left for me to do is to add up those areas. 16 plus 20 plus 6 equals 42 meters squared, and then my job is done. Okay. A different type of area question that you might see is they'll give you something like the figure on the shape and ask you what is the area of the shaded part. So what is the area of the yellow shaded part? And now you'll have to work out the area of the yellow rectangle and the white rectangle, and then you'd have to do something to those answers. So off you go, see if you can work out this problem, and then press play to resume. First, we need to work out the area of the yellow rectangle, okay, and there we've labeled that A. So the area of A is going to be 7 times 8, which is 56 centimeters squared. Then I need to work out the area of B, which is 3 times 4, which is 12 centimeters squared. And then if I subtract the two, 56 minus 12 gives me 44 centimeters squared. Okay, so that's a different type or another type of way of asking area questions. Now we move on to the area of a triangle. And the area of any triangle can be found using the following formula, which is half base times perpendicular height. Okay, perpendicular height is the height from the base of the triangle to the highest point, indicated by the dotted line in the diagram. Okay, or you could use the letters area of triangle equals half BH, and that is the same as saying base times height. You could say base times height divided by 2. We know that when we divide by 2, it's exactly the same as finding half. So there's another option for you to use there. Okay, so that's just a reminder of the area of a triangle, half base times perpendicular height. Okay, so this applies to all triangles, and I've got a slide that will show you different triangles. But you can see from the shape on your screen that I've got a rectangle, and half of the rectangle has been shaded. So the question, what proportion of this rectangle is shaded? You would be quite correct in saying half. So if I work out the area of that entire rectangle, it would be 8 times 4, which is 32. But all I want is half the rectangle, and you should be able to notice that half a rectangle is indeed a triangle. So what I would do is I would halve the 32, and that will give me an answer of 16 centimeters squared. So that's one of the proofs, or one of the theories behind why we say half base times height, is because with a rectangle you got length times width. The width changes to height, and you can see that a triangle is indeed half a rectangle. Okay, so if I asked you again, there's just a little reminder about the area of a right angle triangle. Actually, you can use that area formula for any triangle, and that's just for you to see it by itself without being represented with a rectangle. Okay, so here's a different type of triangle, not a right angle triangle. And again, we need to figure out what proportion of that rectangle has been shaded. It's not as easy to see as it is with a right angle triangle. So if we drew a line on that shape, there you can see we've made two separate rectangles, and now you can see that in each rectangle there's a triangle that makes up half of it. All right, so again we can determine that a triangle is half of a rectangle, so the formula will be half base times height, or half 8 times 4, which is 16 centimeters squared. Okay, so this is an this is a scalene triangle. All sides are different. And here they've extended the drawing using dotted lines to indicate the perpendicular height. All right, so the area of this triangle is going to be half base times height, which is going to be half 7 times 6, which is half of 42, which is 21 centimeters squared. Okay, now we move on to the area of a parallelogram. And remember that a parallelogram is similar to a rectangle, except that it's kind of been pushed over onto its side. Remember that opposite sides are parallel, opposite sides are equal, and the area of a parallelogram is base times perpendicular height. Okay, so similar to a rectangle, when the rectangle was length times width, but now we're still using the length, which is now the base, and we need the perpendicular height. Okay, so using letters, we can say area of parallelogram equals B times H. So if I asked you the area of the parallelogram on the screen, or if you go and work it out and then press play, to see if you've got it. Perpendicular height is indicated by the line which is 7 centimeters long, and you can see it's the perpendicular height because it's got a right angle sign at the base of it. It's got that little square which indicates a 90-degree angle. So that tells you it's the perpendicular height. So that's going to be 7 multiplied by the 12, and that's going to be 84 centimeters squared. And you can see that they've said ignore the length of 8 centimeters, as that is not the perpendicular height. Okay, that is just the length of one of the sides. So really important to notice that when working out the area of a parallelogram, it's not 12 times 8 like it is in a rectangle, but you need to have the perpendicular height to work out the area of a parallelogram. Please make sure you recognize that difference. Okay, area of a trapezium. So the area of trapezium can be used with the following formula: half the sum of the parallel sides multiplied by the height. Okay, so it can seem like a little bit of a mouthful, but half the sum of the parallel sides. So we know the parallel sides are sides A and B, and then we need to multiply that by the height, or by the perpendicular height. And again, the perpendicular height is indicated by the right angle sign at the base. So yeah, A plus B multiplied by, half A plus B multiplied by the height. So important also to recognize that you do the brackets first. So A plus B in brackets, then halve that amount, and then multiply it by the height. So there is an example for you to do. They've given you the length of the parallel sides, 6 and 14, and they've also given you the perpendicular height. So press pause and see if you can go work out that example. Half A plus B multiplied by height. So the first thing we're going to do is we're going to add the A and the B together. That's going to give me 20. So I need to say half of 20 times 9. And remember, the order of a multiplication sum doesn't matter. Either way, you're going to get 90 meters squared. So if you had said half times 20, that equals 10. 10 times 9 is 90. Or you could have said 20 times 9 is 180. And half of 180 is going to give you 90. Okay, so that's the area of a trapezium, guys. Half A plus B multiplied by height, where A plus B is the length of the parallel sides. Okay, so I've got a couple of area problems just to finish off on. So this diagram shows a yellow square inside a blue square. What is the area of the yellow square? Okay, so it's a little bit of a brain bender and a bit of a challenge. But press pause, see if you guys can work through it. Don't rush. Really give it some thought, and then press play and see how you get on. Okay, guys, so to work out the area of the yellow square, we can actually work out the area of the 4 blue triangles surrounding the yellow square, and then subtract that from the total area of the blue square. So the first thing to notice in the question is it tells us that it's a square, and therefore the length of each side is 10 centimeters. So we can work out the area of the triangles because we know that the height of each blue triangle is 7 centimeters. Then we know that the base is going to be 3 centimeters based on the information I've just shown you on the screen. Okay, each triangle is congruent, meaning that each triangle is exactly the same because the yellow square is a square and all 4 sides of the yellow square are also equal. So that's going to give us 4 identical triangles. And if we know the base and the height of each triangle, and if each triangle is going to be identical, then we can work out the area of one blue triangle, which we know the area of a triangle is half base times height. So 7 times 3 is 21, and half of 21 is going to be equal to 10.5 centimeters squared. Okay, so just have a look at that and make sure you understand the work that I've done there. If one blue square is 10.5 centimeters squared, then if one blue triangle is 10.5 centimeters squared, then 4 blue triangles is going to be 10.5 times 4, which is going to give me 42 centimeters squared. And I know my area of the big blue squared is 10 times 10 because all four sides of a square are equal. And then all I need to do is subtract 142 from each other, and that gives me an area of 58 centimeters squared for the yellow triangle. Okay, guys, so that was a bit of an area problem for you to end off on. If you can follow that and understand it, then you should be comfortable and confident moving forward. During our next lesson, I am going to go over a few more area problems, including areas of compound shapes, and we're going to have a look at some real life problems. So make sure you tune into the next lesson to practice some of those and to gain a deeper understanding of the topic on areas. And then just remember the email address at the bottom of your screen, grade7@worksheetcloud.com. Send me any questions or queries, and I'll be happy to go through those with you. Guys, here's your finisher for the week, 24. I'm pretty sure you guys understand how it works, but for those of you who don't, use each of the numbers on each card. So on the first card, you've got to use 7, 3, 4, and 1. And you can use plus, minus, multiply, divide. You don't have to use all the operations, but you need to get an answer of 24. The second part of the challenge is to see how many different ways you can come up with the answer of 24. Cool, grade 7s. Have a really cool day. Thanks for watching. Make sure you have a look at the online activity and memo that I've put up for you. Go back to previous lessons to go over some previous content that we've covered that might not be 100% clear to you. And yeah, keep safe, stay well. Cheers.